Presenting all of Mathematica in a 5-minute video is a bit nutty. You can read about all the very wide range of things it can do online. So I'm just going to show you a little bit about what it's like to work in the Mathematica environment from the point of view of a developer. At its core, Mathematica is a high-level interpreted language that's deeply integrated with an interactive working environment. So what does this actually mean? Let's try evaluating a function that creates a slider. I'm going to type the function in and then hit Shift Return to evaluate it. This creates a slider. This is an interactive user interface element. You can click and drag it just like you'd expect. But because we're in the Mathematica notebook environment here, we can also do things like copy and paste it. So I can copy, paste, make multiple copies. I can also, for example, use that as input. So let's make a table, and I'll paste the slider and say we want 10 of these. So now we get a table of 10 of them. Having used the picture of the slider as an input element in the input language. Because they're all connected here through this dynamic event with the global variable n, when we drag any one of them, they all move. Let's create another dynamic output, in this case a plot, which also depends on the variable n. Now we'll evaluate that function. Now we have the graphic, which depends on the variable n. We move the sliders around, any one of them. The plot moves also. Now you notice that the plot doesn't know about the existence of the sliders. The sliders don't refer to the plot anywhere. The communication happens through the variable n. This is sometimes known as an object view controller paradigm. And it makes construction of these sorts of user interfaces or small applets incredibly simple. And yes, of course, there are also localization constructs, so you don't have to use global variables. Okay, so now this is kind of just showing off, but I'm going to do a little example here. This is a piece of Mathematica code which uses an event handler to trap mouse clicks and then bounces balls wherever you've clicked. So you can click here and get a bunch of little balls bouncing. So this is reasonably compact, and it's a running application here. There's a little bug where they keep bouncing forever, but that's actually kind of nice because it lets you know that it's really still running. But just because this is a running application with internal state, a program counter, whatever, it doesn't mean you can't copy and paste it. So I'm going to copy it. Doesn't mean you can't use it as input. For example, I'm going to type in expand. I'm going to use it as the variable name in a polynomial. So bouncer plus 1 raised to the 5th power. Evaluate that. And now we have the polynomial 1 plus 5 times bouncer plus 10 times bouncer squared, etc. Because we use the localization construct, each of these now has its own internal state, and we can click and bounce different balls at each one. So you might want to just think about that, what that means in terms of a sort of computer science interpretation of what just happened. So moving right along, I'll just delete these annoying outputs here and show you something a little bit more useful. One of the really nice things about version 6 is our data functions, which allow you to bring in large amounts of useful real-world data into Mathematica very easily. For example, here we can make a plot using the element data function. We're going to plot the melting point versus boiling point of all of the elements. Type that in, we evaluate it, we get a nice little scatter plot. No importing data or anything like that, you just have a function, and there's data functions like this available for a wide range of subjects in math, science, politics, geography, finance, all of them, simple functions that allow you to draw in real-world data. Using just sort of one extra line of code roughly, I'm going to paste it in here, and the very high-level manipulate function, we can take an example like that and turn it into an interactive sort of an application. Here you get to choose from all of the known properties of the elements which ones you'd like to plot versus each other. So for example, we'll put hardness there and atomic weight there. I don't know if that's sensible or not, but anyway, you can, if you don't like that, you can choose any other one that you like. There's a good one. Manipulate is an incredibly useful, very high-level way of describing user interfaces like this. We have a demonstrations website that has literally thousands of examples like this, including much more complicated and sophisticated ones that people have developed and uploaded. And we have a free player so that any interactive example like this can be distributed and used by people who don't own a copy of Mathematica. Here's an example of a somewhat larger piece of code that uses the outlining capabilities of the Mathematica notebook interface to organize the code. If we have groups and subgroups here, if we open this group up, we can see there's some code there. Open another one, there's some more code, more code. This interface supports very large programs. It makes it easy to document and outline and see what you're doing. This happens to be an example similar to the one we just did, only much fancier. So it produces an interactive thing like we saw before, but now you can also do things like get a 3D plot of the properties and move it around, or a plot with shaded or ball type representations with tooltips to give you more details and all kinds of things like that.